solving of each equation by factoring. This is on the back of that factor and zero product property ZPP retake packet. So when we have an equation, if we can get it in factored form, if it's set equal to 0, it's really easy to find your solution. So number 49 is already factored for you, right? Doesn't that look like factored form? And you can't factor either of these factors any further. So we're done factoring. Now we just need to solve the equation. We need to figure out what makes the left side truly equal 0, like it's supposed to make the left side equal the right side. So the beautiful thing and what the zero product property says is if you can make this factor right here, k plus 8 equals 0, if this just all becomes a big old 0, 0 times anything, any number is 0. So if I can make k plus 8 that factor equals 0, that's a solution. So what makes k plus 8 equal 0? We'll take k plus 8 and set it equal to 0. You get k equals negative 8. That is a solution. Now they're going to put their solutions in these what I call fancy pants brackets. Oops, so negative 8 is a solution. What can you plug in here for k minus 5 to make k minus 5 equal 0? Well, you solve for k and you get k equals 5. That's your other solution. You might be like, hey, Mr. P, I don't actually need to write the equation or show the work that you just showed. I agree for the most part. Like in number 50, it's already factored for you. And so I can look at the blue factor r plus 6 and know that negative 6 is a solution. However, 5r plus 1, what makes this factor equal 0? That might not be quite as easy to see. So let's set that factor equal to 0 and solve the equation. So we then do addition first by subtracting. And now we divide by 5. So we get r equals negative 1/5. That is the other solution. And then again, they'll write it like this, probably on the right side to check your answer. Try 51 and 52. 53 and 54, though, are not in factored form, so you're going to have to do that. Now, always ask yourself if there's a GCF, a greatest common factor, and there is on 53, you can factor a p out, and then you're left with this. And now I can't factor either of these factors any further. P is as factored as it gets, and p minus 6 is as factored as it gets. I can't square root or cube root both of the terms in that factor. So what makes this factor p minus 6 equals 0? That'd be 6, right? But then this is another factor right here. What makes this equal 0? 0. Yeah, so you get two solutions there, 0 and 6. And if you plug 0 in for p here and p there and type that into your calculator, 0 squared minus 6 times 0, you will get 0. If you plug 6 in instead, you should also get 0. Those are the solutions. Number 54, there is no GCF, but I bet I could factor that thing. There's 3 terms, so I'm going to look for numbers that multiply to 5 and add to negative 6. There you get a negative 2 and a negative 3. Oh, just that? I did not say that. Did not say that at all. Numbers that multiply to 5 are what? 1 and 5. So we need a negative 1 and a negative 5. Let's double check that. Do those two numbers multiply to 5? Yes. Do they add to negative 6? Yes. So these numbers are what go into my factored form. The factors of that polynomial up top is k minus 1 times k minus 5. Now there's still an equation. I set that equal to 0. But you can factor this or FOIL this together, folks, multiply it together, and you'll see that you get k squared. Eventually you get negative 6k, and you do get a positive 5 by taking negative 1 times negative 5. So now that I have it factored, I need to solve the equation. What makes the left side equal the right side? Well, if I can make that blue factor equal 0, 0 times whatever the yellow value is, will equal 0. So k equals 1 is the solution, and k equals 5 is my other solution. You'll find many of these to be similar. Maybe I'll do number 55 here. So numbers that multiply to negative 6 and add to 5. That would be negative 1 and positive 6. So x minus 1 times x plus 6. That's the factored form of the polynomial above. And then that needs to equal 0. So your solutions are going to be positive 1, because if you plug in positive 1 for this first factor, 1 minus 1 is 0, so that is a 0, and so is negative 6 for the other factor. So 1 and negative 6 are your two solutions. Again, number 56, always look for a GCF. You can factor an n out of this. So that is the factored form of the original polynomial. And then your solutions are going to be positive 8. What's your other solution? 0, n equals 0. All right, let's go. Number 59. And this set really right here. Before you can start factoring, we want to make sure that we have the thing set equal to 0. Because remember, we've been talking about what something times some number needs to equal 0. These have all been set up to 0 for you, and it's easy to make one of the factors equal 0. But if I were able to factor number 59 as it is here in yellow, let's do green. I don't know why. If I were able to get that into factored form, better write my factors lower because I know what's coming. Then I'd really have to guess and check what times what equals negative 4. Whereas when we have a 0 over here, I just need to worry about that one factor. What makes that one factor equal 0? Not combinations that multiply to negative 4. That stinks. So let's set this equal to 0 by adding 4. So you get a squared minus 5a. Whoa, come back. Then what do we get there? Negative 14, I think. I don't know. I gotta go look. Come back. There we are. Negative 14, yep. Equals 0. So now you're looking for ways to multiply to negative 14 and add to negative 5. That would be negative 7 and positive 2. I know I did that really fast, folks. Take your time on the other ones. I've done this a lot, so don't get upset if I'm going too fast. Just pause it and then understand the process. So now that I was able to factor this polynomial, this new one that we got by setting it equal to 0, if I can make this yellow factor equal 0, 0 times whatever is in the other factor has to equal 0. 0 times anything is 0. So 7 is one of your answers for sure. But contrarily, if I can make this factor equal 0, what's in blue? If I make that equal 0, 0 times whatever's in yellow also has to be 0. So a equals negative 2 is my other solution. All right, let's go down below. Now down below I made